Very good morning students. I am Sir Rahul Tripathi and I will start chapter first, electric charges and fields. As I have sent you the notes, in notes you might have studied what are electric charges. So charges are actually intrinsic property of a matter. For example, a matter has a mass, in same way it has charge also. So a matter can have two types of charges. How many types of charges? It can have two types of charges. It may have a positive charge or it can have a negative charge. And when the number of positive charge become equals to the number of negative charge, that condition is said to be neutral condition. That condition is said to be neutral when positive number of positive charges become equals to number of negative charges. This condition is known as neutral condition. Okay. So charge, its SI unit is coulomb. Its SI unit is coulomb and we used to denote it by capital C. And its CGS unit is Franklin. Okay. So SI unit and CGS unit and the nature of charge is it is a scalar quantity. Which type of quantity is? It is a scalar quantity. Scalar means it has only magnitude, no direction. Okay. For example, a charge can have 3 coulomb, 4 coulomb, 5 coulomb. Its SI unit is coulomb. Okay. So charge can have any value, but it does not have any direction. Okay. So now moving ahead, we will represent charge. Charge will be represented by Q and Q is known as a point charge. So in this unit, actually this unit is electrostatics. Electro means charge and statics means at rest. So in this unit we will study all the property, all the behavior of a charge when it is at rest, means when it is not moving, because a moving charge constitutes a current. So we will study all the behavior when charge is at rest, not moving. Okay. So a point charge is represented by Q and Q naught a test charge. Test charge. What is this test charge? Test charge is a very small magnitude charge which is used only for experimental purpose. Okay, it is used only for experimental purpose. Now as I said that charge is an intrinsic property of matter and you all know mass is also an intrinsic property of matter. So what are the comparison between a charge and a mass? Let us discuss that. Comparison between a charge and mass. Okay. Need two columns: charge, mass. Let us discuss. First of all, we will discuss dissimilarity. We are going to compare actually mass and charge and mass. We are going to compare. So make two columns. The first is charge can be positive or negative, but mass is always positive. Mass is always positive. Charge can be zero also. Okay. Second, charge is independent of velocity. Charge is independent of velocity. Means charge does not depends on the motion of the charged particle. It will not vary with the velocity of charged particle, but mass depends on velocity of particle. Okay, and this is known as mass dilation. When the particle moves at very high velocity, the mass is dilated, means it varies from the original value. So these are the dissimilarities, and if we will talk about the similarities, first similarity, both are scalar quantity. Second, both are intrinsic property of matter. Okay, so these are the similarity of charge and mass. So you can pause the video and you can make a note of it. Okay, you have to make all these things in your fair note. And also there is a small topic given in the book, Electron Theory of Charge. What is Electron Theory of Charge? Make a note. The elementary charge is electron. Okay, so the basic or the elementary charge available is electron. The electron is the smallest charge we have with us. Okay, so no other charge is smaller than electron, and electron has a value of 1.6 into 10 power minus 19 coulomb. So electron is considered to be the mobile charge, means if an electron leaves a body, means if an electron moves outside a body, it makes the body positively charged. If an electron comes inside the body, it makes the body negatively charged. मीन्स अगर इलेक्ट्रॉन बाहर जाता है तो वो ऑब्जेक्ट को पॉजिटिव चार्ज बनाएगा, अगर इलेक्ट्रॉन अंदर आता है तो ऑब्जेक्ट को नेगेटिव चार्ज बनाएगा. मिला जुला के मतलब यह है कि इलेक्ट्रॉन ही मोबाइल चार्ज है और इसके निकलने की वजह से ऑब्जेक्ट पॉजिटिव चार्ज होता है, इसके अंदर आने की वजह से ऑब्जेक्ट नेगेटिव चार्ज हो जाता है. ओके, now let us discuss the properties of charge. What are the properties charge have? The first property is law of conservation of charge. What is law of conservation of charge? It states that the charge can neither be created nor be destroyed. It can be only transferred from one body to another. One body to another means it cannot be created, cannot be destroyed. It can be transferred from one body to other. Or in other words, we can write is the total charge of an isolated system remains constant. Means the total charge of an isolated system is always constant. For example, if we are having a system and the total charge of this system is 10 coulomb. Let us consider that total charge of this system is 10 coulomb. So this charge can be broken into pieces, but the result should be always equals to 10 coulomb. For example, one charge becomes 4 coulomb, another becomes plus 2 coulomb, another becomes plus 4 coulomb. So the net charge is again 10 coulomb. Okay, so this is known as conservation of charge, means charge of an isolated system always remains constant, or in other words, the charge can neither be created nor be destroyed. Okay, so this law is known as law of conservation of charge. This is the first property of charge. Pause the video and make a note of it in your fair copy. Now let us discuss the second property of charge. The second property is known as quantization of charge. This is second property of charge, quantization of charge. As I already told you that elementary charge or the basic charge we are having is electron. So quantization of charge means what? That charge of a system is always quantized. What do you mean by quantized? Means the charge of a system is always an integral multiple of elementary charge E. The charge of a system, charge you can write it total charge. The total charge of an system is always an integral multiple of elementary charge E. Okay, the total charge of an system is always an integral multiple of elementary charge E. Means any system have the charges in integral multiple of E. What does it mean? For example, let us consider an example. You are going in market to purchase some apples. Okay, if you will ask the shopkeeper for 2.5 kg of apple, he will give you that much of apple. But if you are asking about 2.5 apples, he will not give you 2.5 apples, because 2.5 kg of apples is possible, but it is not possible for him to give you 2.5 apples. वो 2.5 kg एप्पल आपको दे सकता है, लेकिन 2.5 एप्पल्स नहीं दे सकता. इन सेम वे चार्ज हमको 2.5 कूलम या 3.5 कूलम या 9.1 कूलम हो सकता है, बट वी कैन नेवर हैव 2.5 इलेक्ट्रॉन्स, 3.7 इलेक्ट्रॉन्स. इट इज नॉट पॉसिबल. So charge is always quantized. Means the total charge of a system Q is always an integral multiple of electron E. So Q is equals to N into E. This is known as quantization of charge. Okay, this is known as quantization of charge. Now let us discuss the third property of a charge. The third property is additivity of charges. Additivity of charges means the total charge of a system is algebraical sum of individual charges. This property is known as additivity of charges. For example, if we are having a system, Q1 is first charge, Q2 is second charge, Q3 is third charge, then the total charge Q will be equals to Q1 plus Q2 plus Q3. Example, if we are taking, if a system has plus 4 coulomb, minus 3 coulomb, plus 2 coulomb, minus 1 coulomb, then the total charge will be plus 4, minus 3, plus 2, minus 1. This will be the total charge of the system. This property is known as additivity property of charges. Okay, pause the video and make a note of it. And the last property of charge is invariance property. What is this invariance property? This property actually says that charge does not depends on the motion of charged particle. Means if a charged particle is at rest or it is at moving, it is moving in any velocity, the magnitude of charge is not going to change. Means it is independent of motion of charge. The magnitude of a charge is independent of its velocity of motion. Okay, this property actually says कि चार्ज रुका हुआ है या चल रहा है किसी वेलोसिटी से, तो उससे उसके मैग्नीट्यूड पे कोई असर नहीं पड़ेगा, वो चेंज होने वाला नहीं है, वो इनवेरिएबल रहेगा, वो वेरी नहीं करेगा. दिस प्रॉपर्टी इज नोन एज इनवेरियंस प्रॉपर्टी ऑफ चार्जेस. ओके, so that's all for today's class, and we will in next class we will discuss about Coulomb's law of electrostatics. Till then, take care of yourself. Good day.